Our next topic, 8.2b, which is actually section 8.5 in your book, is called slope-intercept form. Now, I've purposely jumped from the table of values in 8.2 to this slope-intercept form because as you graphed using tables of values, you started to notice some things, like this number, this -2, is where it crosses the y-axis, always. And this number is the slope. Whenever I have a function in slope-intercept form, this y equals mx plus b, this b, and I just say b because they decided that would be the y-intercept, and m for mountain or slope. So when I have y equals mx plus b form, remember this from the very first video, this will always be my y-intercept, or where it crosses the y-axis, and this will always be my slope, which is a rate of change. That's true for this one with a positive slope, and it's also true for lines with a negative slope. Y equals -2x plus 4. Notice the b at 4, and the slope is -2. Down 2 over 1, down 2 over 1. That down 2 over 1 that I'm saying brings us to our next point here. When I have slope-intercept form, I'm looking at y equals mx plus b. Again, I'll keep repeating that. Slope and y-intercept. So if I gave you y equals 2/3 x minus 3, you'd say, okay, so I need a coordinate plane, and I'm going to start at -3. And my slope is 2/3, which means my rise over my run is 2 over 3, up 2 over 3, up 2 over 3. You can also go down 2 and back 3 to create this line, which brings me to my next point. The easiest way to think about this rise over run in terms of creating a positive or negative slope is that up and right are positive, and that down or left are negative. So when I went down and left, I created a negative over a negative. And you'll remember from when we did integers that a negative divided by a negative is a positive, just like a positive over a positive is a positive. So how does that affect us if we're supposed to have a negative slope? Well, let's say I have y equals -4x plus 5. Okay, the first thing here that sometimes creates a stumbling block for students is the fact that this doesn't look like it has a rise and a run. But remember, any number can be written as a fraction over 1. So now I have my rise and my run. And I have a y-intercept at 5. 1, 2, 3, 4, 5. Boom. So now if I go down, which I said was negative, I can't go left because that'll be negative over negative and give me a positive. So I go down 4, that's my rise, and run 1 positive to get that point. Or I could go up 4, which would be positive, over a negative. So either a positive over a negative or a negative over a positive give me a negative fraction and give me, more importantly, a negative slope. Y equals mx plus b. Now the last little wrinkle in here is every once in a while you get something that isn't in slope-intercept form. Well, if you're supposed to graph it using slope and y-intercept, you just make it be in slope-intercept form. So I'm going to subtract 2x from both sides. That'll cancel that out. And I get 3y equals -2x plus 15. Y is still not by itself. It still doesn't look like slope-intercept form. So now I'm going to divide everything by 3. And y equals -2/3 x plus 5. My b, or y-intercept, is 5, and my slope is -2/3. And I'm ready to graph this function. I would do that by going to my coordinate plane, creating my x and y axis. When I finished solving that, we had y equals -2/3 x plus 5. So b was 5. 1, 2, 3, 4, 5. Slope is -2/3. Notice I've got a negative slope. I went down and right. Negative over positive created a negative slope for that function.